Introduction to iceberg buoyancy. Icebergs are fascinating natural phenomena that float in the ocean due to their unique properties and the principles of buoyancy. Understanding why icebergs float involves exploring the physics of buoyancy and the characteristics of ice and seawater. Principle of buoyancy. The buoyancy of icebergs is governed by Archimedes' principle, which states that an object will float if the weight of the water displaced by the object is equal to or greater than the weight of the object itself. This principle applies to icebergs, as their density is lower than that of seawater, allowing them to float. Density differences. The key to iceberg buoyancy lies in the density difference between ice and seawater. Freshwater ice, which forms from frozen snow, has a density of about 0.92 grams per cc. In contrast, seawater has a higher density of approximately 1.03 grams per cc due to the dissolved salts and minerals it contains. Because ice is less dense than seawater, it floats on the surface. Iceberg formation. Icebergs originate from glaciers and ice sheets that flow into the ocean. When chunks of ice break off, or calve, from these glaciers, they become icebergs. The process of calving often produces large masses of ice that eventually drift into the open ocean. The icebergs that form in this way have a characteristic structure, with a significant portion submerged beneath the water. Submersion of iceberg. Typically, about 90% of an iceberg's mass is submerged underwater, while only about 10% is visible above the surface. This ratio is due to the lower density of ice compared to seawater. The submerged portion displaces a volume of seawater equal to the weight of the iceberg, which keeps it afloat. The visible part of the iceberg is only a small fraction of its total size. Melting and stability. As icebergs float in warmer ocean waters, they gradually melt. The melting process affects their stability and can cause them to change shape. Icebergs can become unstable and break apart if the melting is uneven, leading to calving of smaller pieces. Despite melting, the iceberg will continue to float until it has melted completely or until it reaches shallower waters where it may ground. Iceberg drift and navigation. Icebergs drift with ocean currents and wind, which can affect their movement and behavior. While drifting, they can travel long distances from their original calving sites. Understanding iceberg movement is important for maritime navigation to avoid collisions with ships and to monitor potential environmental impacts. Implications for climate study. Icebergs play a role in climate studies as they provide insights into glacial dynamics and the effects of climate change. The melting of icebergs contributes to sea level rise, and monitoring their behavior helps scientists understand broader climatic trends and the impacts on polar regions. Conclusion. Icebergs float in the ocean due to the principle of buoyancy, which is influenced by the density difference between ice and seawater. Their formation from glaciers, the ratio of submerged to visible ice, and the effects of melting all contribute to their floating behavior. By studying icebergs, we gain valuable information about ocean dynamics, climate change, and the interplay between ice and water in Earth's environment.